Hello, today we're going to learn the technique of partial fractions. So there are 4 different cases of partial fractions. The partial fractions are when we have to integrate a function of the form a rational function where the denominator has linear factors, linear and non-repeating factors. Okay, so let's show you what does that mean. Here I'm going to first write the function only. This is my function. I need to integrate. This is a rational function. The first step is to make sure you factorize the denominator. The denominator has, this is a quadratic function, so I can factor it easily to be, say, x plus 3, x minus 2, right? So these are two factors of this quadratic function. Both of them are linear and they are non-repeating. That means x plus 3 is only once a factor and x minus 2 is only once a factor. Okay, so that is the first case we are going to discuss. How we proceed towards it to make it partial fractions is we write it in the format of a by the first factor plus b by the second factor. Okay, and then you're gonna say if you can make common denominator on the right side, you'll have to multiply a by x minus 2 and you will have to multiply b by x plus 3 to make the common denominator hold. Now you should compare this with this. These two are equal to each other. Both of them have the same denominator. So comparing, we can say x minus 6 should be equal to a times x minus 2 plus b times x plus 3. This should be true for all x values. Okay, because it should be true for all x values, it should also be true for x is equal to 2. Now you will say, where did you get x equal to 2? I got from one of the factors here. So I'm going to plug, this is true for all x, so it should also be true for x equal to 2. I'm going to plug in x equal to 2 here. X minus 2 minus 6, sorry, is equal to a times 2 minus 2 plus b times 2 plus 3. So this will become negative 4. This will become 0 plus b times 5. 2 plus 3 is 5. So b came up to be what? Minus 4 by 5. That's my first constant I need to figure out. Okay. Similarly, because this is true for all x, this should also be true for, what should be the other number? Negative 3 from the second factor. So now I'm going to plug in negative 3 in there. Negative 3 minus 6 is equal to a times negative 3 minus 2 plus b times negative 3 plus 3. Okay, let's write this down. Negative 9 equal to negative 5a plus negative 3 plus 3 would be just 0. So that means a can be 9 by 5. So we found both the constants here, a and b. That means this fraction can be written now as, in place of a, we can write 9 by 5 by x plus 3 plus b place we can fill 4 by 5 by x minus 2. So we converted our original fraction into two separate fractions. Now let's see, our goal was to solve this integral What partial fractions does is say that this fraction can be written as, this fraction can be replaced by this instead. So I'm going to take 9 by 5 out, 1 by x plus 3 dx minus 4 by 5 out, integral 1 by x minus 2 dx. So instead of that fraction, I can convert into this. And this one is easy integral because we know the rule. Let's see this. Integral of 1 by x dx, you guys know it's natural log of x plus c. On the similar basis, we have another formula. If there is a linear factor, then that would be 1 by a natural log of ax plus b. Okay. So now what that means is that this is a linear factor. The coefficient of x here is 1. This is also linear factor. Coefficient of x is 1. Okay. So that means I can say 9 by 5 natural log of x plus 3 minus 4 by 5 natural log of x minus 2 plus c. So this is your final answer to the integral of the question. And this technique is called integration using partial fractions.